All right, for this video, we're going to show you how to apply the distributive property. A couple things you want to know first are what are equivalent expressions. There are two expressions that have the same value for all values of the variable. An example would be 3 times x plus 2 and 3x, or 3 times x plus 3 times 2. This expression and this expression are equivalent to each other. The distributive property. This allows us to multiply, not divide, but multiply across addition or subtraction. This does not work with multiplying across multiplication. It only works with multiplication across addition or subtraction. So here's an example. A times b plus c is the same thing as a times b plus a times c. And you can see we have an example here. If I have 4 plus 2 inside, which would be 6. 6 times 3 would be 18, so we got to check to see if this side is also equal to 18. So we do 3 times 4 and 3 times 2. We're distributing the 3 to both numbers. We get 12 and 6, which adds up to 18. So the left and right hand side are still equivalent to each other. This also works across subtraction. So a times b minus c is the same thing as ab minus ac, or a times b minus a times c. We can see we get the same thing here. So we have 6 minus 4, which is 2. 2 times 5 is 10. 5 times the 6, distribute, we get 30. 5 times the 4, we get 20. And 30 minus 20 still gives us the 10 that we had over here. Now we're going to actually distribute. Remember, we're taking the number on the outside and multiplying it with each of these terms. So the first thing here would be 4 times y plus 4 times 3. That's one equivalent equation. And then we can simplify it a little bit further. 4y plus 12. And it doesn't matter if your number on the outside is in the front or the back. This still means multiplication. I like to go through and multiply with the first number. Some people like to do it backwards, but for y times y and plus 7 times y, or y times 7. Y times y, that's y to the first times y to the first. If you remember, our exponent rules means that becomes y to the 1 plus 1, or y squared. And y times 7 becomes 7y. Put my plus there. Remember, we like to have the coefficient out in front. 7y. Same thing here. N times n minus n times 9. N times n is equal to n squared, and bring over minus. N times 9 is just 9n. Again, with the number in the back, we have 8. I'm going to multiply by the one up front first. Okay, so 8 times 2 minus 8 times n, and we get 16 minus 8n. And that's how we apply the distributive property. If you want, you can go ahead and try it here. This is applying the distributive property also, only with negative numbers on the outside. The negative must be distributed with both terms, here and here. So this would be negative 2 times x plus negative 2 times 7. And negative 2 times x would just be negative 2x. And negative 2 times 7, negative 2 times x. Negative 2 times 7 would be negative 14, but rather than writing plus negative 14, I'm just going to write it as minus 14, because that's the same thing as plus negative 14. Same thing here, only it's multiplied on the back. So we would have negative 3y times 5, and negative 3 minus negative 3y times y again. Negative 3 times 5, we get negative 15y. Negative times negative is a positive. Positive 3y times y would give you positive 3y squared. And we're going to learn later on that we want to switch that around, put it in descending order. The last one here, this is a tough one for a lot of students to get right. They often ignore that this is a negative 1 on the outside. So if we display this properly, it would be negative 1 times 2x minus negative 1 times 11. So we have negative 1 times 2x, which would give us negative 2x, and that's our multiplication property of negative 1. And then negative times a negative is a positive, and 1 times 11 is just 11. A lot of students forget to take this negative and distribute it to both terms, so this sign will change to opposite like it did, and this sign will change to opposite just like it did there. Terms, coefficient, constant, and like terms. Terms are the parts of the expression that are added. It could be subtracted, but these right here in boxes, everything that's in a box is a term. So I have 1, 2, 3 terms. They're actually separated by pluses and minuses, so I have 1, 2, 3 terms. This right here has 2 parts to it, 2 factors, but it's only considered to be 1 term. So those are the terms. Okay, the coefficients are the numbers that are out in front of the variables. So I've got 1 coefficient here and 1 coefficient here, and they are negative 1 and positive 2. This negative out in front of x is really a negative 1 times x. So the coefficients are negative 1 and positive 2. The constant value is a number that has no variable. Okay, so this right here is the constant. And the last thing here would be like terms. These are terms that have the same variable or variables with the same exponents. Constants are considered like terms all the time. So this is the only constant, so there are no other like terms with it. However, I have 2 x's here, and they both have a power of 1 on them, which means this number and this number, this term and this term are considered to be like terms. So the like terms here would be this one and this one. If this had a power of 2 and this had a power of 1, then they're no longer like terms, because like terms have to have the same exponents. The distributive property allows us to combine like terms. A lot of people know that this is going to make 11n. A lot of people don't know why. So here's why. This can be rewritten as 5 plus 6 times n. So we're undistributing. Later on we're going to figure out that that's called factoring. But this can be written as 5 plus 6 times n with an n on the outside before I distribute it. And 5 plus 6 then it gives us 11n, or 11 times n, which is just 11n. So when you combine the like terms, all you're really doing is calculations on the coefficients. The variables themselves don't just disappear. So it's 5 plus 6, and the n was on the outside and comes along kind of like for the ride. Okay, so we're going to do that here, combining like terms. But before we can do that, you'll notice that I have an n here and an n here inside of parentheses, and we can't combine things that are inside parentheses until I get rid of the parentheses. And then one of the ways we get rid of the parentheses is to use the distributive property. Okay, so we're going to use the distributive property. 4 times n, 4 times 9. So 4 times n is 4n. 4 times positive 9 is positive 36. Be careful here. This is a negative 3 that's being distributed with both of these numbers. So this is a negative 3 times 2, which is a negative 6, and a negative 3 times positive n, which is a negative 3n. Okay, the like terms will be here and here. These are constant values, and they are like terms. These are like terms because they both have n to the first power. So I'm going to start with my n's. So 4n minus, you see a negative out in front of it, or a minus sign, it means minus. 4n minus 3n gives you 1n. And positive 36 minus 6 leaves you with positive 30, so we put plus 30. And some of you might recognize that, well, 1 times n is the identity property of multiplication, which means I don't really need it, so it's just n plus 30. Either one of these is okay, but get used to seeing it written this way, because a lot of the textbooks won't actually put a 1 out in front of it. Okay, for our last one, we're going to talk about what is the perimeter and area. This is the perimeter formula, 2 times the length plus 2 times the width. Area formula is simply length times width. Okay, so perimeter, go ahead and calculate that one first. 2 times But the length, let's call this the length, we'll call this the width, we'll call this the length. The length is actually a binomial, 8 minus 12w plus 2 times w, which is actually 9. So in place of w, I substitute 9. In place of L, I substitute 8 minus 12w. Okay, now I can go ahead and distribute. 2 times 8, 16. 2 times negative 12w is negative 24w. And this over here is just 2 times 9, which is 18. Now I can simplify this a little bit further because I do have two constant values which are like terms, but I don't have any other w's. So I'm actually going to bring my w's up front. I like to put the variables in the front, and that's actually the standard way. However, you got to be careful here because this is actually not just 24w, it's a negative 24w. And then go back and do your 16 plus your 18. Those are constant values, and then you can just put them at the end. Okay, so 16 plus 18 would be positive. It's positive 34, and since it's positive, I'm going to write that as plus 34. And this ends up being the perimeter distance around. Area is going to equal length, which was 8 minus 12w, times the width, which is 9. Length times width. So in place of L, I'm putting in the entire expression for L. Okay, now all I got to do is distribute. Remember, I like to go from the front and then work way backwards. Some people will actually multiply it backwards. It's really up to you. 9 times 8 gives us 72. 9 times a negative 12w gives you a negative 108w. Now, again, like I said, we like to have our, and I left my w off over here. There we go. We like to have our variables up in the front. So if I were to call this plus negative 108w, turn this into an addition problem, then I can apply the rules of addition, or the properties of addition, and move my 108 up front and my positive 72 in the back. So if I were to go ahead and do that, it would look like this: negative 108w plus 72. The negative was attached to the 108, therefore it must follow the 108 wherever it goes. And that is the distributive property.